Hello everyone, so we're going to learn about radicals. And the first lesson we're going to do is radical transformations. So the base radical function is the function y equals square root x. And it looks like this function off to the side here. There's a graph of it. It starts at 0, 0 and it goes up. Okay, it starts at 0, 0 and it goes up. Now so my domain of that here is that it's going to be x is greater than or equal to 0. What would change that is if I had a stretch. No, a horizontal stretch wouldn't change it because you'd be multiplying by 0. Would a reflection? Yeah, a reflection in the y-axis would cause it to be less than, right? So instead of being greater than or equal to 0, it now would be less than. And what else would change it is a horizontal translation. So if I moved 4 to the right, the whole graph would move 4 to the right. So it would look like this. So my domain would be x is greater than or equal to 4. So my domain is fully based on my horizontal translations. And if there's a reflection, if there's a horizontal translation, it'll be greater than or equal to that. And if there's a reflection, it will be less than or equal to that. Okay? Your range is always y is greater than or equal to 0, unless you have a reflection in the x-axis. Then it would be less than or equal to 0. And what else could move it? A vertical translation. Okay? So your vertical translation can move your range, and your horizontal translation can move your domain. And if there's a reflection, it makes it less than. And if there isn't a reflection, it makes it greater. And the stretches don't affect your domain and range at all. Okay? Here on the list, you can read it yourself. It goes through how the transformations happen, but it doesn't change anything from when we did transformations before. So we flip to the next page. We have the equation here. It says, explain how to transform the graph of y equals square root x to obtain the graph of each function. State the domain and range in each case. So the very first thing we have to do is always make sure that our horizontal stretch, that's in y equals, and that our horizontal stretch or reflection is pulled out, and that we have a 1 in front of the x, which we do because there's already a bracket. So this one's in a good form already. So then we can just state our transformations. So we have this 3 in front. And remember, our transformations have to be stated in the order stretch, reflect, translate. So we have a vertical stretch. Don't mind my writing. I'm using a tablet. It's not very great. Vertical stretch by a factor of 3 about the x-axis because it's a vertical stretch. I have no horizontal stretch because I have no number in front of this x in the bracket. I do have a negative in front though. That negative is a reflection. If it's underneath the square root, it's with the x. So I have a reflection in the y-axis because it's with the x. And then I have no other reflection because this 3 here is positive. And then all I have left is my translations. So here is a vertical translation. Two down, because remember it just stays what the sign is. And I have an x plus 4, so I have a horizontal translation. 4 left, because it's always the opposite. Now what I was saying on the first page is your domain is affected by anything in here, right? And remember, stretches don't affect your domain. Your domain of the original square root x function is greater than or equal to 0. This graph has been flipped in the y-axis, so it's been reflected in the y-axis. So now my domain is less than or equal to, and it's been moved 4 to the left. It was at 0, it's now been 4 to the left. So now it's at negative 4. So my domain is going to be x such that x is less than, because of the inequality, less than or equal to, and I move 4 to the left. It was at 0, so less than or equal to negative 4, XER. And then if I want that in interval notation, so that's set notation. If I want an interval notation, I'm going to go from negative infinity to negative 4. Square bracket because it's equal to. And remember, you can type these into your calculator because they don't have the little f in the equation. If it doesn't have an f in the equation, remember, you can type them in and look at them. So that would be a way to check it. Your range is affected by your y's. Now, stretches don't affect it because if I multiply by 0, any number, it'll stay 0. So the only thing I'm looking for is a reflection in the x, which there isn't one because it's a positive 3. So my range is going to be greater than or equal to because there's no reflection. And instead of it being at 0 now, it's been moved 2 down. So it's going to be minus 2. YER. So that's set notation. Y is greater than or equal to negative 2. In interval, I'm going to go negative 2 square bracket because that's equal to infinity. Okay, let's look at the next one. B. B is y equals negative 2, 4x minus 12 plus 5. The very first thing I need to do is actually take that 4 out. So I'm going to get y equals, so I'm going to put an equal sign, negative 2 square root, take a 4 out, x, and when you take a 4 out of negative 12, you get negative 3, because when you take the 4 out of GCF, you're just dividing. And then a plus 5 at the back. And then I state my transformations again. So, the stretches are what's in front, just like before. Nothing has changed. So I have a vertical stretch, by a factor of 2. The vertical stretch never flips as long as it's in y equals. Factor of 2 about the x-axis. I really need to get a new stylus because this one makes me look like I'm in kindergarten. So vertical stretch by a factor of 2 about the x-axis. A horizontal stretch by a factor of, and it always flips, remember? Words and mapping are the same. The equation is not. So horizontal stretch by a factor of the reciprocal of 4, which is 4 over 1. So this is going to be a factor of 1/4 about the y-axis. We have a negative in front, right here. It's with the y, so that's a reflection in the x-axis. And if I forgot to take that 4 out, I would say my horizontal translation wrong, right? Because here it looks like it's 12 to the right, but it's not actually 12 to the right. It's 3 to the right and vertically 5 up. So don't forget to take that horizontal stretch or reflection out. So we have a vertical translation. Not 3. Silly. Oh no. Vertical translation, 5 up. And a horizontal translation, 3 to the right, not 12. Just to remind you of mapping. Remember that mapping, ooh, that's a terrible heart. Mapping and words are the same, right? They're besties. Okay. Did I mention how much I miss you guys? Super miss you guys. So, that's an aside. I miss you. So we still have to do the domain and range. The domain is based on if it's negative in front, if there's a reflection so we're looking at domain is what is affected by the x. Is there a negative in front? No. So if there's not a negative in front, my domain is going to be x such that x is greater than or equal to, because it didn't flip it. It didn't reflect it in the y. And normally it's at 0, but it's been horizontally translated 3 to the right. So the graph is actually going to be greater than or equal to 3 because it's moved 3 to the right. XER. And then if it's greater than or equal to 3, that means it starts at 3 and it goes to infinity. And remember, the round bracket is on infinity because it's a concept, not a number. It can't be equal to it. And the square bracket's on 3 because it's equal to. Now your range is affected by your y's. Pick another color. Red. So we have this -2 in front. The -2 means it's been reflected in the x-axis. So I know my inequality now is actually not going to be greater than or equal to. It's going to be less than or equal to because the whole graph is going downwards. And remember, you can type these into your calculator and check them too. So it's going to be less than or equal to 0 normally. But I moved 5 up. So now the entire graph has been moved 5 up. So it's going to be less than or equal to 5. So your vertical translation helps you with your range on a radical function, and your horizontal translation helps you with your domain. YER. Now, it's going to be less than or equal to 5. So it's from negative infinity to 5, square bracket. Okay, one more. Whoa, what happened there? Let's undo that. Oh my goodness. Oh my goodness. All right, let's look at this one. So the first thing we have to do, we have to remember to take that 5 out because I need to have a 1 in front of my x. And currently I have a 5 in front of my x. I need to be a 1 or my horizontal translation is going to be wrong. So I'm going to put a 4 and then I'm going to go square root 5. Take the 5 out as a GCF and I'm going to be left with x plus 1 bracket and then a -4 at the back. You see their translations like normal. I have a vertical stretch because of the 4 in front. I have a vertical stretch by a factor of 4. Oh my goodness, this writing is terrible. About the x-axis. I have that 5 in front of that x, so I also have a horizontal stretch. But remember, it always flips when it comes out of the equation. Horizontal stretch. Oh my goodness. By a factor of 1/5. About the y-axis. No reflections because the 4 in front doesn't have a negative in front and the 5 doesn't have a negative in front. So no reflections. I just have horizontally 1 to the left, not 5, because you have to remember to take that 5 out. So it's 1 to the left and vertically 4 up or 4 down. So I have a vertical translation. Four down. And a horizontal translation. Oh my goodness. Translation. 1 left. So my domain is affected by my x. Boom, 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 boom. Okay. Is there a negative in front of that 5? No. So there's not a reflection. So if there's no reflection, my domain is going to be greater than or equal to, because it didn't flip. Normally it's at 0, but it's been moved 1 to the left. So it's going to be greater than or equal to -1. X is an element of the reals. If it's greater than or equal to -1 in interval notation, I'm going to start at -1 and go to infinity. My range is based on my y's. So this 4 is not negative. So my range is going to be greater than or equal to, because it didn't flip it. And normally it's at 0, but now I moved 4 down. So it's going to be greater than or equal to -4. YER. And so I'm going to start at -4 and go to infinity. All right. next question. Remember, you can pause along the way if it's going too fast, okay? P.S. I miss you. Okay, so use mapping notation. Now, mapping and words are the same thing, remember? So we're going to use mapping notation to show how the graph square root of x becomes this new graph. The first thing I need to do, though, is I need to rewrite this with the 3 taken out. The negative 3, taken out. So that my horizontal translation isn't wrong. So I get a negative 3, take out a negative 3 out of that. I'm left with x. And then negative 6 divided by negative 3 is actually positive 2. Plus 1. So I'm actually moving 2 to the left, not 6 to the right, which makes a big difference. So let's do our mapping. So my x values are affected by everything here, right? So I'm going to multiply by negative 3. No, I'm not, because it's a horizontal stretch by a third, and words and mapping are the same. So I'm going to actually multiply by negative a third. Oh my goodness, it gets worse. That's a 3. Multiply by negative a third x, and then I'm going to subtract 2, because I moved 2 to the left. And then on the outside, I have a negative 1. So I'm going to multiply my y by negative 1, y, or just negative y, and I'm going to add 1 to all my points. So in order to do mapping, I have an x and a y, and this is for my y equals root x. So if I start off with x is 0, and I plug that in, I get root 0. So my y is actually 0. So 0, 0 is an original point. This is going to be hard to graph, so bear with me. And then if I plug in a 1, the square root of 1 is 1. So I have another point at 1, 1. And then I'm not going to do 2 because square root of 2 is a decimal, but you could do it. 3, not going to do that because square root of 3 is a decimal. I'm going to do 4 because square root of 4 is 2. So I have a point at 4 and 2. Oh my goodness. Yep, there it is. And then 5, square root of 5 would give me a decimal 6, square root of 6 give me a decimal 7, 8, and then I pick 9 because 9 is the next perfect square. And the square root of 9 is 3. So my other point, wow, I'm having problems with 3's. Uh-oh. So square root of 9 is 3. So now I have a point at 9 and 3. Hey, that's not too bad. I'm actually impressed with myself. So that is the graph. The red one is y equals square root x. Okay? Now I'm going to take those points and I'm going to map them. Okay? So my points are normally x, y, but they're becoming negative 1/3 x minus 2, comma, negative y plus 1. And I'm going to do them in light blue. Okay, so my first point is 0, 0. When I fill it into mapping, I'm going to get negative 1/3 times 0 minus 2, comma, negative 0 plus 1. So negative 1/3 times 0 minus 2 is negative 2, and then 1. 0, negative 0. So my new point's at negative 2 and 1. Okay? Then I'm going to use the point 1, 1 off the original, and I'm going to map it. So I'm going to get negative 1/3. Wow, my 3's stink. Negative 1/3 times 1 minus 2, comma, negative 1 plus 1. So negative 1/3 minus 2. You can plug into your calculators if you want. So we're going to get negative 1/3 minus 2 is going to be, I'm going to put negative 2.3 repeating. And the reason why I'm putting it as a decimal is because it's actually negative 7/3, which I don't know what the heck that is on the graph. So I'm going to go negative 2.3, repeating just so I can sketch it. And then negative 1 plus 1 is 0. So I put this little dot for repeating. So negative 2.3 repeating and 0. So it's somewhere right there. Okay? And then I'm going to do 4 and 2. So I get negative 1/3 times 4 minus 2, comma, and then negative 2 plus 1. I'm just filling it into my mapping. That's a plus sign. And so I get negative 1/3 times 4, which is negative 4/3, and then minus 2, which, as a fraction, is negative 10 over 3. That's hard to graph. So I'm going to graph negative 3.3 repeating. And then comma, negative 2 plus 1 is negative 1. Okay. Then I'm going to do the last one. I'm just going to do it over here because it's easier to write if I'm not squishing. So 9 and 3 is going to become negative 1/3 times 9 minus 2, comma, negative y, so negative 3 plus 1. So negative 1/3 times 9 is negative 3, minus 2 is negative 5, comma, negative 3 plus 1 is negative 2. So my other new points at negative 5 and negative 2. And so my graph is doing this, which makes total sense because there's two reflections. So the graph was up and to the right, it's now down and to the left. And your domain and range are going to change because they're going to be less thans because of the negative signs. And it moved 2 to the left, so my domain is going to be less than or equal to negative 2. And my range moved 1 up, so it's going to be less than or equal to 1. Okay, so that's that page. The next thing I can do is I can give you words and ask you to make the new equation. So write the radical function that results from applying each of the sets of transformations to the graph of y equals root x. So I know that this has no translations on it. Remember, if it had translations, you'd have to take all the verticals and apply them to the verticals. Like, this is way easier. You can just apply them because the original graph has nothing on it, which makes it super awesome. So if you had a vertical translation, remember, you'd have to multiply your vertical stretch by it, but you don't. So this is easier. So we have a vertical stretch by a factor of 3 about the x-axis. So I am going to get a 3, which my pen does not like writing. See, ooh, that's not too bad, in front of my root. Okay, I have a reflection in the x-axis, so that affects my y's. So I have a negative 3. I have a translation 4 units right, so I'm going to have x minus 4, because so is the opposite, and 2 down, minus 2. Then I have a horizontal stretch by a factor of 1/4 about the y-axis. So that's going to affect my x. But remember, mapping and words are the same, but words going into equation always flip with your x's, right? So instead of it being 1/4 in front of the x, I'm going to have a 4. And then I have a reflection in the y, so I actually have a negative 4 because it affects the x. Translation 3 up, so I have a plus 3 at the back. And 5 to the left, so I need to go bracket because I need to have a 1 in front of my x. X plus 5. And that's it. And you can try these before you listen to me doing them because you have a hang of it and you guys know how to do this, okay? P.S. I miss you. All right. Vertical stretch by a factor of 2 about the x-axis. Vertical stretches never flip. Whether it's words, mapping, equation, it always stays the same. It's always those horizontal ones that flip. So vertical stretch by a factor of 2. So we're going to get a 2. Horizontal stretch by a factor of 3 about the x-axis. So I'm going to get that 1/3 inside. Translation 1 up. So I'm going to go plus 1. And 4 left. So I'm going to go x plus 4. And then the last one, Vertical stretch by a factor of 3 about the x-axis. Vertical stretches never change, so I'm going to have a 3. Horizontal stretch by a half about the y-axis. Look at how good I am at underlining. I'm so impressed with myself. Okay, so horizontal stretch by a factor of a half. So I'm going to get a 2 because it always flips. Reflection in the x and y axis. So these are both negative. When they're both in both axes, it's easy. You don't have to use any brain power. Great, right? And then a translation 6 left. So I go bracket x plus 6. And I always have to do those brackets because I need to have a 1 in front. Okay? Boom. Drop the mic. We're done that one. Right? Right. Okay. Next page. So that's all we do for transformations, okay? Transformations of radicals. Our other lesson is square root of a function, but I'm going to record it separately. So these are the 2 lessons that are due for this week, all right? And all that's due to hand into me in the end is the weekly assignment, which is in Google Classroom, okay? That's it, just the weekly assignment, and it's due on Sunday. But if you get it into me earlier, that's awesome, okay? All right. See you in a little bit on the next lesson.